Hi and hello to everyone. In this video, we are going to see about the convolution technique in continuous time domain. We are going to work out two problems using graphical approach. In the last video, we have seen the how to do what is convolution, how to do convolution for a in discrete time domain. Right now, we are going to work with continuous time domain. Welcome to the lecture. Okay, quickly we'll brush up what is convolution. See, it's like if we need an output of any system can be obtained by convolving the input with impulse response h of t, right. So this is how we represent a convolution, right? X is the input, h is the impulse response. This star symbol indicates, this asterisk symbol indicates that convolution operation. Okay, so if we you know the impulse response of any system, then for any input, if you convolve with the impulse response, you will get the output, right? So again we'll see what is impulse response. If you take a linear time invariant system, this is a continuous time system as well as it is linear time invariant LTI system. Okay, for a linear time continuous time linear time invariant continuous time system, if you give the impulse input, that's delta of t, we'll get the output that represented by h of t. H of t is nothing but impulse response. Okay, so once you know the impulse response, what you can do, you can put impulse. If you know the impulse response, then for any input x of t, then what I can obtain the y of t just by convolving the input with impulse response. Okay, that's what I mentioned, the impulse response which represent the system. Fine. Okay, here the objective is the if the input and impulse response is given, we will find out the output. For that, we are working out two problems. This is the shorthand notation. We will use the asterisk symbol or star symbol to represent x of t convolved with h of t. Input convolved with impulse response. Mathematically, what is convolution operation is represented as y of t is equal to x of tau h of t minus tau d tau. Okay, here tau is ranging from minus infinite to plus infinite, or else see x of t convolved with h of t, or else it can be h of t convolved with x of t. It's commutative, right? We have explained all these properties in the previous video lectures. I can, instead of writing this, I can write it like this also: h of tau x of t minus tau d tau. Right? Both gives the same answer because x convolved with h or h convolved with x, both are same. These are the mathematical expression for convolution. We'll be using this expression and we'll use the graphical technique to find out the output. Okay, this is the convolution expression, right? X convolved with h. What is the procedure? If x and h are given, the input and impulse response are given, the procedure to be followed is first rename x of t to x of tau. Similarly, h of t to h of tau. Just you have to rename. Instead of t, you have to make it as tau. Okay, so we got x of tau. Right? Next, we need what? We need x of tau. We need h of t minus tau. So find out h of t minus tau. Okay. In the step 1, we found out what is h of tau. Just replace t with tau. Now what you have to do is here. Now hereafter h is a function of only tau. Now you have to shift t units and time fold. Okay. Already I explained how to shift, time shift, and then you have to go for time folding. Okay, now we have x of tau, we have h of tau, we have. Okay, we have x of tau, but now we can multiply. That's what you have to do. You have to multiply both the signals. Then what you have to do, once you have found out x of tau, h of t minus tau, then you have multiplied, then you have to go for integration. Integration is nothing but finding the area of the signal in step 3. Thereby you can get the output. It's very simple procedure, right? First thing, just replace t with tau for both x and h, then find out h of t minus tau. Here the caution is we have to do with respect to tau. Okay, shift with respect to t, then you have to time fold with respect to tau. Here tau is the variable. Okay, tau is the independent variable. Then you have to multiply x of tau with h of t minus tau. Then you have to find the area. Okay, this is the first problem I have taken. Find the convolution of the signal is given as x of t e power minus t u of t, and the impulse response is given as u of t minus 1. We know what is u of t. U of t is nothing but unit step signal. What is unit step signal? For a positive value of time, that is 0 to t, it is amplitude is 1. For the negative value of time, it is 0. This signal is called unit step signal. Okay. What is e of minus t? That is an exponentially decaying signal, right? Since you are multiplying with u of t, this is applicable only for the positive time, because u of t is equal to 1 for only t greater than 0. That's what you mentioned here, right? And e power minus t, so it's exponentially decreasing signal. Okay, this is how the signal. Now I have replaced t with tau. That is the first step. So this is how the signal will look like. E power minus tau. You can check, use your calculator. You put tau value 0, e power 0 is 1, tau value 1, e power minus 1, e power minus 2, it keep on decreasing. E power minus 5 will be very close to 0. Okay. For tau increases, it decreases. Okay, that's we say exponentially decaying signal. Next, what about u of t minus 1? We need u of tau minus 1. Okay, that's h of tau we need. H of t is given, you have to replace with t with tau. T minus 1 is nothing but delayed. U of t is this, t minus 1 means delayed by 1 time unit. So delayed by 1 time unit. Instead of starting at 0, it starts at only 1. Okay, first step is completed. We got x of tau and we got h of tau. Next we have to find h of t minus tau. H of t minus tau. For this, first thing we have to do shifting. Okay, first you have to do shifting of how much unit? T time units you have to shift. You have to shift t units. You have to shift t units. Okay, so if you observe this, where the signal, this is your h of tau, we need h of t plus tau, so you have to add t. So instead of 1, it will be t plus 1. Can you understand what is the relation between h of tau and h of t plus tau? Because this signal is shifted by t time units, because t plus tau. So instead of starting at 1, it starts at t plus 1. Okay, right. Next is, but we need h of t minus tau. First you have to do shifting, then we have to do time folding. Here time folding means don't think it's t. Here the independent variable is tau. So you have to fold the tau. Okay, what are the tau values here? 0, 1. This is tau value. Instead of 1, now it will become minus 1. That's called time folding, like a mirror, right? So the signal which is in this right side will come to this, will be like a mirror image to the left side. So this part of the signal will be shifted, time folded. Okay, fine. That's your t minus 1. Okay, now we got okay, now what are things we have now? We have x of tau, we have h of t minus tau. This is your h of t minus tau. Okay, now we have to multiply. You have to multiply x of tau with h of t minus tau. Observe this is x of tau. This is moving with respect to t, right? So for various values of t, you have to compute, right? First thing, you observe this signal, this is only present for the positive tau value. Okay, but here if you take case 1, I am taking where t is less than 1. T is less than 1. Take it, say value t less than 1, like t equal to 0. 0 is less than 1. So if you put t as 0, it becomes minus 1. The signal is from minus 1, minus 2, only this side, right? But if you multiply with this, you will not get any answer, right? So for t less than 1, the product of these two will be 0. Okay, right? Now next, for t greater than or equal to 1, if you put t as 1, what happens? 1 minus 1, 0. Okay, then you put t as 1.1. 1.1 minus 1, 0.1. 0.1 is overlapping with this because it is for positive tau value. Okay, so for t greater than 1, greater than or equal to 1, this part will be moving to the right side. Okay, this signal will be moving to the right side, thereby it can overlap with this if you can multiply. Okay, that is why when I multiply, I will get this part, this exponential signal, and the upper time limit is t minus 1. Okay, for both the cases, for t less than 1 there is no common path between these two. For t greater than or equal to 1 I have this. Next, you have to step 4, you have to find the area. For the case 1, okay, for the case 1, that is, since it is 0, if the area is 0, for t less than 1 it is 0. Okay, come to the case 2, for t greater than or equal to 1. What is the signal? This signal is e power minus tau. Okay, e power minus tau. So e power minus tau d tau. Right? What is the limit? 0 to tau equal to t minus 1. Okay, so you have to integrate e power minus tau. If you integrate, you get minus e power minus tau. Then you have to substitute the tau limits 0 to t minus 1. Substitute the upper limit, then substitute the lower limit, you get this value 1 minus e power minus t minus 1. This is applicable only for t greater than or equal to 1. Now we have to plot. Okay, so what is the output? This is the output. This is the output y of t is nothing but convolution of x of t and h of t. I have written the expression, convolution expression, right? For t less than 1, for t less than 1 it is 0, we don't have any signal. For t greater than 1, what do you have to do? For t greater than 1, you put t as 1, e power minus 1 minus 1 0, e power 0 is 1, so 1 minus 1 0, t equal to 1 it is 0, right? When t increases, if you put various values of t, put values of t equal to 2, 3, 4, 5, e power minus 5 is 0, so approximately at t equal to 5, at t equal to 5, at t equal to 5, this term becomes 0, ultimately it becomes asymptotic towards 1. Okay, so this is how the signal will look like. You can roughly plot, right? You put t equal to 1, 2 first. T equal to 1, if you put e power 1 minus 1 0, 1 0, e power 0 is 1, 1 minus 1 is 0, we got this value, right? T equal to 2, if you put e power 2 minus 1, e power minus 1, 1 minus e power minus 1, it will be approximately 0.6 something, right? You get this value, 0.3 something. Okay, so thereby you can plot for 3, 4, 5, it's like this, you get the signal. So this is the output. Okay, this is the output once you convolve x of t and h of t, right? Quickly I will refresh again, right? Okay, just listen again, right? The question, x is input is given, impulse response is given. First step, rename into x of tau and h of tau. You have to know how to plot the signal first. Exponentially decaying signal multiplied with unit step will have only for the positive time, and this is u of t minus 1. U of t minus 1 is delayed by 1 time unit. Instead of t, I am replacing with tau. Okay, next step, you have to find h of t minus tau. For this, we have two operations. We have h of tau, we have found in step 1. Now to find h of t minus tau, you have to be doing first time shift operation. What is time shift operation? H of t tau is shifted by t plus t units. Okay, so instead of starting at 1, it will start at t plus 1. Okay, it will start at t plus 1, right? Now after shifting, now we have to do time folding. Time folding means don't think we are folding with t, we are folding with tau, because now the independent variable is hereafter only tau. Okay, so instead of wherever tau is there, tau values are the 0 plus 1 is tau value, right? So instead of t plus 1, it is becomes t minus 1, right? So this is the signal. Time folding. It's like a mirror. You keep a mirror image in y-axis. The signal in the right side will come to the left side, and the left side will go to the right side, right? So you have to keep a mirror. So they call time folding. So we got h of t minus tau. Now what you have to do is you have to multiply. You have to multiply x of tau with h of t minus tau. That's the third step. Okay. Now you have to see that once you multiply for multiplication, you have to change the t value, right? For various values of t, you have to do. Okay. For various values of t means first case I am taking is t less than 1. Okay. Because this signal is present only for positive tau value. But here I am going to move this part. Move h of t minus tau. I am going to vary the t. For t less than 1 means you put any value less than 1, right? Like 0.9, 0.8, minus 2. If you put, what happens? There is nothing common between these two. So the answer is 0. The product is 0. Next, you have to, next value is t greater than 1, greater than or equal to 1, right? If you put t equal to 1, what happens? Observe closely. T equal to 1 means 1 minus 1, 0. So this part of the signal will be overlapping with this. Okay. Next, if I am increasing t 1, 1.1, 2.1.2, 1.3, 1.4, I keep on increasing, what happens? This will be keep on moving. So this will be keep on moving over this. It's very, very important, right? Okay, you just place this over this and move it. Okay, then you can find out the upper limit of the time is t minus 1. Right? Once we found out the product of x of tau and h of t minus tau, next we can find the area. Right? Since the product is 0, area is also integration. Area, finding the area is nothing but integration, right? It is 0. For t less than 1, it is 0. Then for t greater than or equal to 1, tau limit is 0 to, what is the tau value? 0 to t minus 1, e power minus tau d tau. Substitute the upper limit and lower limit, you get this expression. This is valid only for t greater than or equal to 1. Next, you plot the values. For plotting the value, I always say that put some sample values. Okay, this is clear, right? For t less than 1, it is 0. For t greater than or equal to 1, we get this expression. You put the sample values. Put the t value as 1, t value as 2, 3, 4, 5. You get some values. You plot it. Okay, at 5, at t equal to 5, if you put here e power minus 5 minus 1 is very close to 0. So you will get it like this. Okay, so this is the output, right? Okay, we'll move into the second problem. Okay, this problem is this is also we are going to work with the graphical technique. Here the input, instead of expression, the input is given as the signal itself, right? Between time 0 to 2 it is 2, and the impulse response is between 0 to 1 it is 1. The first step is rename with x of tau with h of tau. X of t with x of tau, h of t with h of tau. Okay, I have renamed. Instead of t, I put a tau value. Instead of t, I have put tau values. Okay. Next is second step is find h of t minus tau. Right? What is the first step? First I have to do shifting, then I have to do folding. First shifting by t time units. Look, where the h of tau is, it is from 0 to 1. Right? I am going to shift with the t. So what happens? 0 will move to t, t will move to t plus 1. Okay, h of tau is there. This is h of t plus tau is there, right? This is 0 to 1 means this becomes 0 plus t is t, 1 plus t is t plus 1. This is your h of t plus tau. Now we have to do time folding. Time folding here to do with respect to tau. Okay, because the independent variable is tau. So 1 will become minus 1. Okay, so time folding. So this part of the signal will go to the left side. Okay, right? So this is called time folding. So t plus 1 will become t minus 1. So this has come here. You can make a highlight it for you here, right? This part of the signal has come here. Okay, right. Now, we have obtained h of t minus tau. We have x of tau, we have h of t minus tau. Now next third step is we have to multiply these two. Okay, we have to multiply. So for our convenience, I have written separately, written here. This is your x of tau, this is your h of t minus tau. We have to multiply. Here, for multiplication, it is very clear that x of tau is between 0 to 2. But here you are going to vary the values of t. We know the time varies from minus infinite to plus infinite. But for a particular time only, this part will overlap with this. Okay, right? If it is here, the answer is 0. If this segment is here, the answer is 0. Okay, so we have to find out for what values of t it is overlapping. Okay, for that, obviously, we are taking the case. This is all using your common sense or by experience only you can obtain this value. Okay, if you work out few problems, you get an idea, right? First thing for t, I am putting t less than 0 value. T less than 0. Can I come with a value? Right, I can say t is minus 1. If I put minus 1, what happens? Minus 1, minus 2. Here t is minus 1. So minus 2 to minus 1. Okay, first I am taking for case 1, I am taking t as minus 1. So what happens to the limit? The time ranges from minus 2 to minus 1. Okay, now if we compare this is from 0 to 2, this is from minus 1 to minus 2. Is there any common part between these two? There is nothing common, right? So the answer is 0. So the answer is 0. Okay, right. Next. Next I am taking t between 0 and 1. Why I am putting 0 and 1 is, you observe closely here, if I put 0, it becomes 0 to minus 1, right? If I put the upper limit 1, what happens? T equal to 1. Now I am going to put t equal to 1 for the case 2. T equal to 1 means what is the limit? 1 minus 1 is 0, this is 1. 0 to 1. 0 to 1. Okay, now this part will move into this 0 to 1 is common between 0 to 1, right? That's why by varying, this is the upper limit, I have put 1, right? But t is from 0 to 1. Okay, so simply for varying the upper limit, I have mentioned it as t. Okay, so put t as 0, we'll get, see, very clear. Put t as 0, you will get 0 minus 1. Here this is 0, right? So this part, right side of the h of t minus tau will overlap with x of tau. Only this part will be moving towards the right. Once I increase t value, up to what value? T equal to 1, right? So up to 0 to t, 0 to t, this is 1 multiplied with 2, the answer is 2. That is the product. 0 to t, answer is 2. This is the product of x of tau, h of t minus tau. In the third case, between 1 and 2, between 1 and 2. Now substitute the lower limit. If you put 1, 1 minus 1, 0, right? So this part of the signal will overlap with this, right? And if you put the upper limit is 2, 2. Okay, upper limit is 2, so it will be here, right? So between t minus 1, between this will be between t minus 1 and t. Okay, just by looking at the lower limit and upper limit, that's your t as 1. You put t as 1, it is 0, it's here. But since it is moving, we will get the range between t minus 1 and t. Next case, between, sorry, okay, fine. t between 2 and 3. Okay. Okay, what is here? If you put t value 2 minus 1, it's 1. Here it is 1. Sorry, if put, okay, if you put 2 and 3 means I can help you like t value lower limit is I'm putting as 2. So 2 minus 1 is 1, and here it is t is 2. Between 1 and 2 it is overlapping. Okay, between 1 and 2 it is overlapping, right? And if you increase beyond 2, like 2.1, 2.2, 2.3, up to 3, 2.5, if you put, what happens? The signal is from only 0 to 2, but this is going beyond 2. Okay, that is why upper limit I have set to 2. The product, if I multiply this with this, the upper limit is 2 and the lower limit is t minus 1. Okay, now last case, I am increasing beyond 3. Beyond 3 means what happens? 3 minus 1, 3. It's if you multiply, this is going greater than 3, this is greater than 3, but it is up to only greater than 2. Actually, if I put 3 means what happens? 3 minus 1 is 2, this is going up to 3. Okay, if the product of these two is always 0, right? Now we have to find the area, right? What is the for case 1 and case 2? It's obvious that since the product is 0 for the case 1 and case 2, for the case 1, for t less than 0 it is 0, for t greater than 3 it is 0. Okay, so for case 1 and case 5 together I have done, right? Then go for the case 2. What about case 2? Yeah, here it is, case 2 is there. Just a moment, I'll keep it in one screen. Okay. Case 2. Case 2, what is the limit? 0 to t. 0 to t. What is the product of these two? It is 2 d tau. So if you integrate to 2, I will get 2 tau. Then substitute the limit t minus 0. You get 2t. Okay. Come to the case 3. For case 3, it is between the t minus 1 to t. T minus 1 to t. If you integrate 2 d tau, we will get a 2 tau, substitute the limit t minus 1. So upper limit is t, lower limit is minus of t minus 1. So it is minus t plus 1. T gets cancelled, it's 2. Then go for the case 4. Case 4, the time limit is t minus 1 to 2. T minus 1 to 2. Then again integration of 2 d tau is tau. Then substitute the upper limit 2 minus the lower limit is t minus 1. So minus will get inside. So minus t plus 1. So it becomes, if it becomes 3 plus 3 minus t, you multiply with 2, you get 6 minus 2t. So that the limit is it is applicable only for the t limit is 0 2 to 3. Okay, now in the integration we have found out the area, right? Then I can plot it, right? Okay, we'll start with the case 1 first. In the case 1, for t less than 0 it is 0, for t less than 0 there is no signal. Similarly in case 5, t greater than 3 there is no signal. Between t is between 0 and 1, 0 and 1, between 0 and 1 the signal is 2t, right? So how to plot it? You can like get it like you can take samples, right? First you put t as 0 here. T as 0 means what happens? T as 0 means 2 into 0 will get 0. Okay, then t as 1, instead of t as 1 you can put like 0.5 sample, another sample. We will get 2 into 0.5, we will get 1. Then t as 1, you will get 2. Okay, that's what we have done here. Like at 0, you can look here at 0 it is, at t0 it is 0, at 0.5 it is 1, Okay, at 0 it is 0, at zero point 0.5 it is 1, at 2 it is, at 1 it is 2. It's a slope. Okay, then we'll go and look into the between the time limits 1 and 2. 1 and 2 it is 2. Between time 1 and 2 it is 2. Right. Next, I have to plot 6 minus 2t between the time 2 and 3. Okay, I can have the same approach. T equal to 2. If I put t equal to 2, what happens? 6 minus 2 into 2 equal to 2. Next is t equal to, I can put it like 2.5. What happens? 6 minus 2 into 2.5 is 5. We'll get 1. T equal to 3. 6 minus 2 into 3 is 6. 6 minus 6 is 0. Okay, you can get the values, right? At t equal to 2, it is 2. At t equal to 2, it is 2. Here it is 2.5 is between 2 and 3. At 2.5, it is 1. At 3, it is, at t equal to 3, we get 0. So this is the answer. Okay, here you people may feel that how to take the time limits, right? Always remember, I will explain again. Be finding out the various time limits, you may be confused, right? Use your common sense. We are going to move this signal on this signal. Okay, this is constant, this is stationary, this is not going to move. Only this h of t minus tau is moving with respect to how much value. We are going to change the t value. If you are moving into this, okay, keep this, suppose this signal is here, it is 0. If this signal is going here, this is also 0. Now we have to find out if it is here, if it is in the center part, if it is this part, what is going to happen. That is what explained here, right? For t less than 0, if you put t less than 0, entirely it is here. For t greater than 3, it is entirely here, we get 0. Only for these three cases, it is overlapping some part. Okay, that part I have drawn here. Okay, we practice these problems, right? In the textbook few problems are given, please work out those problems. I hope you learned something useful from this video. Thanks for listening. Do subscribe the channel. Any doubts, please ask in the comment section. Jai Hind.